So this is an introduction to data mining. This is the first topic that we're going to cover in data mining and warehousing. All right, so today we're going to cover, first of all, why data mining, why, where did it come from? Why did it exist? Um, what is data mining? We're going to explain what is data mining. We're going to talk about the knowledge discovery process and its relation to data mining. We're going to talk about what kind of data can we use in order to mine and what kind of patterns that we can uncover from mine data. We're going to talk about technologies that are used in data mining, and we're also going to talk about what kind of applications that can be targeted by data mining. And this part, the kinds of applications to be targeted by data mining, can give you some inspiration regarding your project later on when you start working. Okay, why data mining? We have an explosive growth of data, meaning that we have availability of data. We have a huge amount of data available. All systems around are generating data. And this data availability makes it or have makes um, uh, 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 that we have an abundance of data. We have too much data, which is fine, but having too much data is also an opportunity that we need to utilize so that we can benefit from the data. So data availability is actually what drove data mining to happen. If we don't have enough data, data mining will not be a possibility. So if we have data and we don't utilize it, we are actually missing on opportunities to uncover things that we are not aware of. طيب. So this means that we have a society that is data rich, but if we don't utilize this data, if we don't use it, if we don't look into it, we will have poor information. And even further, we will have poor knowledge. This is a view showing the development of databases in time. And the reason that we're studying this because there is a connection, there is a relation between data mining and databases. Why? Because databases are the structures where we save the data. In the 60s, and probably earlier in the 60s, databases were not advanced. They were very simple. Their simple task was to save the data and to retrieve the data. That's it. Now, after 70s and until the early 80s, DBMSs appeared. And DBMSs are the systems that we use to manage data. And DBMSs appeared, and also uh, um, database schema started to appear, meaning that the way we save the data is now more structured. So we either have a relational database, we have an object-oriented database, we now create data models using entity relationship models. We are more in contact with the databases. We create queries, we create user interfaces with the data, we create reports. So now we can do more with the databases. After the mid 80s, databases witnessed advances. And these advances, to be summarized, are about the availability or the ability to save complex data types. So we are able now to save spatial data, temporal data, scientific, engineering, moving objects, multimedia, structured, unstructured data. All types of data now are supported and can be saved by databases. Also, we have web-based databases. The XML appeared. We have the concept of semantic web, which means that web pages are able to speak to each other without intervention, sending and receiving data from each other. Now, these advances, it's not important that we go through them in details, but we need to understand that this new advance in databases supported multiple data types, and this is actually directly related to our data mining concept, because data mining is about mining the knowledge from all types of data. Now, when the advances of database systems happened, advances in data analysis also took place. So now we are able to create data warehouses, and we're going to explain later what a data warehouse is. And OLAP, we also started to do data mining and knowledge discovery, and these include classification, clustering, outlier analysis, association, correlation, and etc. And all of these, we're going to talk about them, pattern discovery and etc. We're going to talk about them. We started mining complex data types, and we started applying data mining in various businesses. Now, this is actually where we are right now, the advances in data analysis or data analytics. Okay, and the future is predicted to even be better. So instead of doing data mining manually, as we are going to do in this course, the future is that information systems are going to do that automatically. So with just one click, you will be able to see predictions, you will see classifications, you will see clustering and such. Right. So, what is data mining? A definition, so this is one of the definitions of data mining, is that it's about extraction of interesting, non trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. So let's just ignore what's between the brackets. So extraction of interesting patterns or knowledge from huge amount of data. This is the definition. But what are the characteristics of these patterns? They are non-trivial. Non-trivial meaning they are not اعتباطية, or they're not عشوائية. They are implicit, meaning that they are within or from the data. Previously unknown, احنا قلنا انه hidden is the key word here. So we did not know that we have this pattern. And they are potentially useful. Potentially useful in terms of making decisions, using them, or just knowing them is actually useful. Data mining can also have alternative names. Sometimes it's called knowledge discovery in databases, or KDD, and we're going to discuss KDD process in a minute. Also, knowledge extraction, this is another name, data or pattern analysis, data archaeology, which means tanqib, data dredging, information harvesting, business intelligence. Now, these are not exactly the same meaning, but there is enough overlap between them to make it safe for us to call them alternative names of data mining. Another way of explaining data mining is that we extract knowledge from a large amount of data, and we usually do that automatically. It's usually automatically created. I'll give you an example of an application of data mining in the health industry. Now, Corona is what we're going on right now, and this is probably the most unknown thing known to us right now. It is something that's going on. No one understands it. No one know things about it. So there is ongoing research in biology, in chemistry, in the medical field, and in data mining, trying to understand what's this virus about. One research that was published about corona, it was very useful, is that they identified six types of corona. They identified that there are six types of corona, and types of corona here is referring to the severity of the symptoms, how bad the symptoms are. So what did they do? They collected data from people who got infected by corona, asked them to record their symptoms. So some of them said, I have a fever. Some said, I have nothing. Someone says that I lost the sense of taste and smell. Some reported, heavy, that they are not able to breathe. So there were many people who responded and many people who provided different symptoms. What they did is that they collected this data, and using data mining technique, specifically clustering, and we're going to talk about that in a bit, they grouped, they found that many people had similar symptoms. So this is what the first group, and many others had similar symptoms. So that's the second group, and so forth. So they grouped people based on their symptoms, and they discovered that, generally speaking, there are six types of corona based on the symptoms. طيب. Now, knowledge discovery process, or a knowledge discovery in databases process, and I want you to notice the name. It's saying knowledge discovery in databases. It means that we can have knowledge discovery that is not in databases. So the process of knowledge discovery in databases starts by having a database. And this database will be cleaned, databases, not only one, will be cleaned and integrated. Cleaned, we're going to discuss what's cleaning is, but cleaned means that if there are missing values, we were going to deal with them. If there are wrong values, if there are irrelevant values, if we're going to look into the values and we're going to clean them. And integrating means that we will be combining these databases together and store them in a data warehouse. And as I said, we have like 3 weeks of data warehousing towards the end of the semester. Now, the data warehouse, as the name suggests, is a place where we save huge amount of data. So it's like a repository or a, let's say, a مخزن بالعربي. Okay. And the data warehouse is where we save the data, but we also select data from where the data warehouse. We select the data and transform its type into a type that can be used in data mining. Right. After selection and transformation, we will be applying data mining techniques, and this is what we are learning in this course. And after data mining techniques, we will end up with results. Now, these results are the patterns that we are looking for. However, these patterns are usually displayed in numerical way. So these are numbers. So we will need to evaluate these patterns. We want to see if they are, or if they have value. And then we will, based on that, based on the evaluation, we are going to present them in a form, in a visual form, or in a report that can be read and understood by people who are not specializing in data mining. And after that, we arrive to knowledge. So this is the process of knowledge discovery in databases. It's also the process, if you notice, it includes the process of data mining. So data mining is part of the knowledge discovery in databases. طيب. So these are the steps which I just explained: data cleaning, integration, selection, transformation. data mining, pattern evaluation, and then knowledge representation presentation. Now, you will notice that these steps are similar and available in under different names, but eventually it is the same. We have to clean or do pre-processing. We have to select the data that we're going to use. We apply data mining. We uncover patterns. We evaluate these patterns, and we also present them in a visual or in a report form type. Now, the idea of having uh, KDD and data mining as synonyms, which means that they are they are used interchangeably. As we said that KDD is an alternative for saying data mining. But you noticed from the process just right now that it's actually not the case, that the data mining is included in KDD. However, you cannot do data mining without preparing the data first, without having it ready. Okay? Now, this is another view of the KDD process showing that we actually collect data from a domain, a certain domain, banking, healthcare, school, university. So this is the domain. So now we will have a different types of data. And we do not have, if you notice, we do not have to store it in a warehouse. So a data warehouse is not essential to data mining, but it is an option for organizations to keep data in data warehouse if we, in case we need to do some data mining later on. Now, we do set goals before we start our analysis in our targeted data, and then we do data mining, and we also evaluate and present and utilize or benefit out of the results. I want you to notice something. Now, this is the process of data mining where we have a target data, we have processing, pre-processing للدata، نعمل transformation للدata، نختار which data mining method to do. We get numerical results of patterns, and then we do visualization. These steps from the target data to visualization is actually happens between these steps here: target data and visual patterns and models. Now, a data warehouse, as I said a minute ago, is actually a place where we save data. Now, this place is actually allows us to collect data from multiple multiple sources. This can be data from databases, files, textual files, some social media data. So different types of data, some audio, some video, some GPS data. So all of these data are stored in a data warehouse under a unified schema. And I mentioned a schema earlier, and I said that we have relational schema, we have object-oriented schema, but the thing is the data warehouse will have only one schema, and all other data that are going to be saved in the data warehouse will follow up with the same schema. So if we have a relational database and the data warehouse follows an object-oriented database, the relational database has to be converted into an object-oriented database before being inserted into the data warehouse. Now, constructing the data warehouse means that we need to first clean the data, integrate the data together. We transform the data to match the unified schema. We also load the data into the data warehouse, and every now and then we refresh the data. And we're going to talk more and more about data warehousing towards the end. So this is just a general view of the process of creating the data warehouse from different data sources. And we clean, integrate, transform, load, and refresh them into the data warehouse. And then clients or administrators or decision makers or whoever is going to benefit from the data warehouse will run queries, which means that they will retrieve information, or they run analysis tools, which means that they will run data mining tools to retrieve knowledge out of the data warehouse. The data in the data warehouse is saved in a form of cube. We're going to explain how a cube is formulated, what is the contents, how is it accessed, and such, inshallah, later when we discuss data warehouse. Now, one of the data that is hugely available in the meantime is data coming from the web. So we said that the KDD is knowledge discovery in databases, which means that we're discovering data, we're discovering knowledge from data in databases. However, we also have data from other places, as I said. It can be from places that are not in a database. And in this case, the example here is from the web. And web mining is a very hot topic in terms of research. It's something that everybody is doing right now because the web and the social media are generating a huge amount of data that provides us with insights and information that is very useful. Of course, if we are doing web mining, we need to clean the data, we need to integrate it from multiple sources. Sometimes we want to warehouse the data, or we would simply analyze it directly. Also, in order to warehouse it in the data warehouse, we need to create a data cube, okay? And if we are going to do data mining, we will be selecting data from the saved data, and we will conduct data mining, and we will also be presenting the mining results, as we said, in forms of charts or reports. And finally, we will arrive to knowledge that is useful for decision making or for only knowing. Now, data mining in business intelligence is not only about the process of creating the data, it's also supporting decision making. So, business intelligence is actually utilizing data mining and making decisions for future benefit of the business. An example of that, a very interesting example that I ran across once, is that Walmart in the US, using the purchase data of customers, they found out that that the customers buy a certain brand and a certain flavor of jam at a very certain time of the year, and they have no explanation for that. Suddenly, at that time of the year, in the winter, all people just start buying this brand and strawberry, actually, flavor of jam. And for them in Walmart, they did not care why. It's not important for them to know why, but this is knowledge that they can benefit of. So a business decision in that case would be that they will start, or they will make sure that they will have enough stock of this jam during the specific time that they discovered. Now, data mining, if we're going to talk about data mining from the point of view of machine learning and statistics, so data mining is actually done in various techniques, and we're going to talk about the different techniques in a minute. But from the most popular technique that we use in data mining is machine learning and statistics. And the machine learning actually goes through, or examples of machine learnings is pattern discovery, association and correlation, classification, clustering, outlier analysis. And we're going to discuss each one of them in brief after a few minutes. So for those who are focused on machine learning and statistics, data mining is mainly about that. Preparing the data and doing or running a machine learning model or statistical analysis on the data, and arriving to conclusions. So arriving into patterns where they have pattern evaluation, selection, interpretation, and visualization. So for them, they do not care about um, what decisions are made based on that, on these results, which happens after the data mining, and they do not focus a lot on the creation of the data warehouse or the integration of data, or no, they only focus on preparing the data, analyzing the data, and arriving to results. And it's known that um, um, uh, machine learning, data mining in general, has a strong tie with statistics, and those who are who work with data mining usually have strong background in statistics. Now, these are the techniques. I already mentioned statistics and machine learnings that we apply to data mining. However, we also need to have knowledge about database systems, about data warehousing, a bit about information retrieval. We want to know about the applications that we use in data mining, such as Weka that you're going to use in your lab. There are other applications, of course. We're going to, you need to know a bit about visualization. I think they give you in the lab some Tableau tool to work with in order to create visualizations, pattern recognition techniques, also some algorithm design, and most importantly, high performance computing, because high performance computing includes or allows us to process a huge amount of data in a short time. And in data mining, the more data you have, the more or the better results that you have. So high performance computing is something that is considered important and important part of data mining. طيب, now thinking about the different views that we just explored, اللي هي ال KDD, الماشين learning, البزنس intelligence, المفروض انه ما يكون عندنا preference. يعني المفروض انه ما يكون نقول نفضل انه احنا يكون هذا تركيزنا في الداتا مايننج او هذا تركيزنا. basically لانه كل واحد فيهم عنده its own function وعنده ظروفه الخاصه وعنده its own applications. ففعليا ما في تفضيل. We cannot say that it's better to focus on machine learning and statistics, or it's better to focus on the business decisions that we base on data mining. لا, هذه تعتمد على the context. What are we using data mining for? طيب, الآن الداتا mining عندها multiple dimensions. Actually عندها 4 dimensions. The first dimension هو data that we are supposed to mine, the data that we are going to look into. وقلنا إنه الداتا هذه ممكن إنها تكون from many different types. ممكن تكون object oriented, ممكن تكون مخزنة في data warehouse, which means that it's معناها أنواع مختلفة من الداتا. ممكن تكون text, graphics, time series, ممكن تكون stream data. والstream data تحديدا المثال الأشهر عليها هو مثال الweather sensors. الداتا اللي بترسلها الweather sensors. الweather sensor هو جهاز صغير هدفه إنه يجمع data about the weather ويجمعها بصورة مستمرة، يعني every second بجمع هذه الداتا. هذه الداتا ممكن تكون data about the temperature, about the humidity, about the اتجاه الرياح, about الرطوبة. فبتتجمع هذه الداتا وبتكون موجودة في السنسر. so هذه بنسميها stream data لأنها مستمرة. Another example of stream data هي اليوتيوب لايف فيديو مثلا. إنها it's actually happening right now, so this is a stream of data that we are receiving. فهذه الأنواع كلها عندها تحدياتها when we want to analyze it, عندها مشاكلها، ولكن this is one dimension اللي هي data to be mined. السكند dimension هو knowledge to be mined أو اللي هي data mining functions, and this is what we are mainly studying في هذه المادة. الداتا مايننج فانكشنز منها عندنا الكلاسيفيكيشن هي اول وحده راح نتعلمها. عندنا راح نتعلم الكلاسترنج، في عندنا الاوتلاير اناليسيز، عندنا الترند والديفيشن والكاركترايزيشن والديسكريمينيشن والاسوسيشن، يعني امثله كثيره جدا على الداتا مايننج فانكشنز. احنا راح نتعلم جزء منها بس as I said that this is considered to be an introduction to data mining, and in real life new functions are always introduced and new ways are always introduced. But generally speaking data mining functions تعمل حاجة من الاثنين، إما descriptive data mining أو predictive data mining، وحنعرف الفرق بيناتهم in a minute. الدايمنشن الثالث هي التكنيك that we utilize. هل هي لو فاكرينها اللي تكلمنا عنهم من شويه اللي هو الماشين ليرنينج، الستاتستكس، الانفورميشن ريتريفال، الفيجواليزيشن، هاي performance computing، هذه هي التكنيكس اللي بنستخدمها with data mining. اخر حاجه هي الابلكيشنز اللي احنا بنطبق عليها. يعني هل احنا بنبحث في داتا خاصه بالتليكوميونيكيشن؟ هل احنا بنبحث في داتا خاصه بالبانكينج؟ هل احنا بنبحث في داتا خاصه بالسوشيال داتا، هيلث داتا؟ فالدومين، المجال اللي احنا شغالين فيه is actually considered another dimension. So ايش هي ال dimensions of data mining؟ Data to be mined, knowledge to be mined, the techniques that we utilize, and applications that we adopt. طيب أعتقد إحنا we covered this earlier لما تكلمنا عن الأنواع المختلفة that we use with data mining. زي ما قلت في عندنا structured data، عندنا unstructured data، عندنا textual data، عندنا multi media data، عندنا videos، عندنا audios، عندنا streams، عندنا time series، كلها هذه أنواع and we are going to talk about them وإيش فروقاتهم من بعض. But the thing is data mining is applicable to all these types of data and options. طيب من شوية قلت إنه data mining can either achieve descriptive mining or predictive mining. Descriptive mining الهدف منها to describe something right now, what is going right now. مثال عليها اللي هو مثال كورونا that I mentioned earlier. We have data and we are describing the data. عندنا describing the types or the clusters of coronavirus based on symptoms. هذا descriptive. البريدكتيف مايننج اللي هو مثال عليها انه كانه لما بنستخدم الستريم اوف داتا. الان الستريم اوف داتا احنا الويذر سنسورز تحديدا قلنا انها بتجمع ويذر داتا. الهدف الاساسي منها انها تعطينا تورينا the current condition, weather conditions, but at the same time احنا ممكن نستخدمها to think or to predict what is the weather condition ممكن after 24 hours أو مثلا نفس هذا اليوم next year أو إلى آخره. So predictive معناها using data, current data to predict future situations. والتو functions هدول كل الشغل بتاع الداتا مايننج بيصب ما بين هدول الفانكشنز. طيب خلونا ناخذ امثله على الداتا مايننج functions اللي احنا بنستخدمها او اللي راح ندرسها from now on. اول data mining function هو association analysis او بنسميها association rules. association معناها ايش بنقول عليها؟ ارتباط. association analysis تحليل الارتباط something like that. طيب الآن مثال حلو ممكن يفهمنا هو يقول لك this representation shows إنه X اشترى كمبيوتر، إذا X راح يشتري سوفت وير. أوكي؟ بما إنه X اشترى كمبيوتر إذا X راح يشتري سوفت وير. هذه كيف طلعناها؟ جبنا purchase data ولقينا إنه الناس لما يشتروا كمبيوتر بيشتروا ايضا سوفت وير. فهذه ايش بنسميها؟ هذه بنسميها association. الان هذه القيم اللي هي السبورت والكونفيدنس احنا ما راح نتكلم عنها الان كيف انحسبت، ولكن it means how confident are we about this, how confident are we about this association rule. اوكي حسب الداتا اللي عندنا يقول لك 50% احنا confident. Another example يقول لك إذا كان الشخص عمره ما بين 20 و 29 سنة ودخله ما بين 40,000 and 49,000 في السنة إذن راح يشتري لابتوب. So it's an association rule. حاجة طلعناها out of the data and we are 60% confident of that إذا كان الشخص عمره ما بين 20 و 29 والإنكم بتاعه ما بين 40 و 49 ألف في السنة they will buy a laptop. وقيسوا على ذلك هذه association rules. زي مثلا فكرة إنه اللي راح يشتري واحدة كانت interesting في one of the research اللي هي إنه اللي راح يشتري قهوة most likely راح يروح يشتري اللي هو إيش بيسموه الكريمر بتاع القهوة. So this is an association rule and based on this السوبرماركتس تضعهم جنب بعض، تعمل عليهم اوفرات مع بعض، يعني تخليهم في طريقه هو ماشي. So it's always they construct things based on these associations. طيب second function هو الclassification function. الclassification function معناها إنه أنا أعطيكم إياها. Let's give it to you through an example. So a classification function إنه I'm working on a research right now about discovering fake accounts in Facebook. Okay, so based on that I have two classes. So either the account is fake or the account is not fake. So these are two classes. I want to say if I have an account, I want to say that this account is fake or this account is not fake. Now, based on that, or how to do that in order to achieve the classification function, I will obtain accounts that I know that they are fake, and these will be labeled as fake, and other accounts that I know that they are not fake, and these will be labeled as not fake. Now, إيش استفدت من هذا الكلام؟ راح أدخل هذه الداتا اللي فيها fake accounts certain and not fake account also certain into a machine learning model, and this model will learn automatically based on the characteristics of each account إنه إيش اللي خلاني أقول إنه هذا fake وهذا مش fake. Once the model learns أي account تعطيه حتى لو مش محدد that it's fake or not, the model will be able to predict if it's fake or not. So it's actually predicting the class. This is what we call classification. وclassification عندها many models or methods: decision tree, naive Bayesian, عندنا support vector machine, neural networks, rule based classification, pattern based classification, logistic regression. هذه كلها methods that are used in classification ومستخدم وعنده تطبيقات كثيرة زي الدايجنوسز. مثلا حد يقولوا انه عنده a certain disease or not. fraud detection زي هذا الفيك، هذا يعتبر fraud detection. إلى آخره. So this is the classification. As I said, we have 2 weeks about classification, inshallah, that we are going to discuss. The third function, oh, sorry. So this is the representation of classification using if-then rules, اللي هي association rules, just like the ones we've seen earlier, but in this case we're using them in classification, and using decision tree. Based on the age, if the person is middle-aged, we will say that they are in class C. And if they are youth and they have high income, they will be in class A. If they are youth and they have low income, they will be in class B. So it's just a way of classifying people based on their age and their income. And this should be done automatically. So once you train the model to do that, it should be able to do it automatically. The third function here is the clustering analysis. And I gave you an example of that based on the corona types. So clustering is actually following something that we call unsupervised learning. So in the classification, which we call supervised learning, we train the model. We tell it, this is what's fake and this is what's not fake. But in clustering, we don't train it. We don't give it labels. We just give it the data and tell the system to group them accordingly. And this is what happens in clustering. And in the example of corona, the clustering function, what did it do? It simply took the patients and it groups them based on their symptoms. So we will end up with something like that. Similar or data that is close to each other are considered to be one group. So here we have 3 clusters of data, or 3 classes of data, or 3 groups of data that were created by the cluster function. The last data mining function here is outlier analysis, and outlier is the data object that is different from all other data. Okay, so everybody's money in the bank are between 2,000 and 100,000, but there is one person whose money is over 500,000. So in this case, this person is considered to be an outlier. In some cases, outliers are not desired. So if we are doing classification or clustering, we don't really need or we don't really want outliers. But in some cases, we want to find the outliers because outliers can give us new knowledge and new information. Now, these are examples of applications of data mining, but I think throughout the lecture, I mentioned many examples and many ideas of applications in data mining. However, it's safe to say that it is applicable in all domains, including education, including entertainment, e-commerce, banking. All domains are actually considered to be data mining or can be applied into data mining. Right. A summary. So we introduced what data mining is. We defined it. We introduced KDD process, and we said that it includes data cleaning, integration, selection, transformation, mining, pattern evaluation, and knowledge representation. We also talked about that mining can be performed on many types of data, and we gave examples of these data. And we spoke about some data mining functionalities. We said that data mining is either descriptive or predictive, but we spoke about particularly association, classification, clustering, and outlier analysis, but there are others. And we spoke about some data mining technologies and applications. Thank you very much. I will stop here.